Howdy, this is the second video on using the factorizing technique completing the square. So if you haven't watched part one, please do so before having a look at this one. So in this example here, x squared minus 8x plus 11, we are going to use the completing the square method, and it's the same method, but we have a difference here of having a negative or a subtraction of this term here. And I wanted to remind you that we have the pattern of a plus b all squared is a squared plus 2ab plus b squared, and a minus b all squared expands to a squared minus 2ab plus b squared. So really it's exactly the same pattern, except that this middle term here, the sign of it, determines what the sign is here, and that's it. Note that in both cases we've got plus b squared here. It's important. I'll tell you why in a second. So we start off the process exactly the same way. So I start with going bracket x, like so. And then I look at the middle term, which is 8, and I divide it by 2 to get 4. But this time, because this is a subtraction here, I'm going to make sure that this is a subtraction in here, and I'm going to complete the square. And here's the killer. Don't then assume that you're going to add 4 squared to the end. It's exactly the same as we did in the last example. We then subtract 4 squared and then add the 11 as usual. The reason why this changes but this doesn't change is because what we're effectively doing is we're subtracting the b squared away from the plus b squared we've just added in here. That's what we're doing. Okay, so be careful of that. We keep the signs the same and we're always subtracting at the end. Okay, I'll move through this pretty quickly then. So that would be x minus 4 all squared, and we can do this bit in our head, I hope. That's minus 16 plus 11, and so we've got minus 5. It is possible to fully factorize this. It's not very useful, but sometimes you are asked to do it. But just to point out that this is the format that we will find most useful in later work. But if you did have to fully factorize it, do note that any number can be written as a square number by taking the square root of it first. So 5 is the square root of 5 squared. So due to that, if I wanted to, I could turn this into a difference of 2 squares if I wanted to. Rarely do I want to, but I just wanted to point out that it is possible to do so. Okay, so that's example 4 done. Switching on to example 5 now. What makes this different? You can pause the video if you want, have a look at the previous examples, see if you can figure out why I chose this as an example for its different property. Okay, so if you pause it, I wonder whether you came up with this. If you look at this middle term here, we have an odd number. Don't let that throw you. It's okay, but just be mindful that you have to then deal with fractions, which is not everyone's cup of tea. So I go x, that's a plus, so I'll make it a plus here as well. And then I have to halve 5. Now you can put 2.5, but often it's not great to do that unless you are really, really trying to avoid fractions. So it's 5 on 2. It's just that number on 2. Squared minus 5 on 2 squared plus 1. And we can simplify that. If you have your calculator, it will do it nicely for you. But it's okay. We can do it. X plus 5 on 2 all squared. Now, minus 5 on 2 all squared, you simply square the top, square the bottom to get the resultant fraction, plus 1. And then we're going to simplify that fractiony bit on the right there. So x plus 5 on 2 all squared. So I'll just do this bit in our heads really, but we've got 1, which is actually 4 on 4. So we've got minus 25 4s, and or divided by 4, and we're adding 4 on 4. So minus 25 plus 4 is minus 21. So we end up with minus 21 on 4, which if we wanted to, we could then fully factorize from there, but I'm not going to for the sake of having a shorter video. Example 6. Again, pause, think about it. What makes it different? can you see a way you could solve this? All right, you might have seen that we now have a number in front of x squared. So in other words, a is not equal to 1. So we can still solve this. We can still do it. In this instance, we just need to remember that the very first step in factorizing is to determine if there is a number that is outside, that is common, there's a common factor to all 3 terms, and 2 is here. So I can write 2 outside of x squared plus 8x plus 2. And now you can work with this to make it into completing the square bit. Like it's a mini problem inside the brackets effectively. So I will go 2, and I'm going to use square brackets here just to help not get too confused with the inside brackets. X, half of 8 is 4, so x plus 4 all squared minus 4 squared plus 2, close that square bracket, which equals 2 outside of x plus 4 all squared minus, do this in our head, minus 16 plus 2 is minus 14. And then, although that's in some ways a better factorized form, if I want to get it into the form that I want completing the squares to often be in, I'm actually just going to do a quick expansion. So I'm left with 2 outside of x plus 4 all squared, and then 2 times 14 is 28. So that's now in the right form, I suppose, for completing the square. Example 7. What makes this different from example 6? Pause, think about it, come back. Okay, did you notice that although 2 and 4 is a common factor of 2, has a common factor of 2, it's not a common factor of 1, so we can't use the same format. So this is how we go about doing it. We put 2 outside of, I'm going to use the square brackets again, just these 2 terms, because ultimately these are the 2 terms that are controlling this completing the square method. So if I take 2 outside of those 2, I'd be left with x squared plus 2x, and then I've got my plus 1 at the end. Okay, you can expand that if you don't believe me. It will give you the top line there. Now I'm going to use my completing the square method. So I've got 2 outside of x plus 2 divided by 2 is 1, so it's x plus 1 all squared minus 1 squared plus 1. I'm now going to expand the brackets again. So I've got 2 outside of x plus 1 all squared. And again, just a bit of head work. 1 squared is 1. Careful, it's not minus 1 squared. It's take away 1 squared. So 1 squared is 1. 2 times 1 is 2. So I've got minus 2, and then the plus 1 from outside the square brackets. And then I'll just tidy it up from there. X plus 1 all squared minus 2 plus 1, which is minus 1. There we go. And I can't use difference of 2 squares here because that 2 here is preventing me from having a square minus another square. Unless I wanted to turn it into root 2 or something like that. Okay, so that's the examples, all the examples I wanted to go through. I'm going to do a bonus example on the next page. And it's just to answer the question, well, what happens if there's no common factor here or here or here? What do we do then? And the answer is pretty simple, and maybe you can figure it out for yourself. But if you want to keep viewing the video, I'll go through one more example. There we go. So this is example 8. And I'm just going to change the previous problem just slightly. And I'm going to use perfect squares, so completing the square in order to solve this particular problem. Now, the critical thing is there's no common factor, but it doesn't mean we can't factorize with horrible numbers, I suppose. So whatever we do, whatever this number is here, we factorize out the a value, the number before x squared. So I'm going to put the 2 outside the square brackets here, and now I'm going to figure out what it will look like inside these 2 terms, remembering that these are the 2 critical terms for working out completing the square. So 2 times x squared, what is it? 2 times 2.5 would work. But basically, if I take the number, in this case 5, I'll just do that little thought bubbly thing again. If I take the number and divide it by 2, then I know that when I multiply it by 2, I would get the number again. Okay, so basically all I have to do is take the number and put it over 2, and then I'll be fine. Okay, so that's x squared plus 5 over 2x plus 1. And now I'm just going to follow through with my usual process. So I'm going to go 2 bracket x plus, and now I have to halve 5 over 2. So I'll just do it intuitively and then maybe explain. That would be 5 over 4 all squared. And then straight away, I take away the 5 over 4 all squared and then close the square bracket. And then there's the plus 1, which I haven't dealt with yet. So that's the completing the square done. Now, for those of you that weren't quite sure, if I start off with 5 over 2, like so, I like to spell these out because sometimes they're not clear to people who are a bit poor on their fractions. If I start off with 5 over 2 and I'm halving it, that's effectively multiplying it by 1 on 2. So if I multiply the tops together, I get 5, and when I multiply the bottoms together, I get 4. So that's where the 5 on 4 comes from. Okay, I'll just finish off this problem. It's a bit of a horrible one, which is why it's in the bonus extended remix version of this video. But bear with me and we'll go from there. So 2 square bracket x plus 5 on 4 all squared minus 25, 5 squared, over 16, 4 squared, plus 1. Now I'll expand the brackets. 2 outside of x plus 5 on 4 all squared minus 2 times 25 over 16. That means the 2 is going to go into 16 8 times, so I'm left with 25 over 8. Again, little thought bubble. Fast forward if you don't know, if you're fine with this fraction work. Thought bubble is, it's a horrible thought bubble, isn't it? Is that I've got 25 over 16. I'm multiplying it by 2, and all integers can be written as a fraction by putting it over 1. And then I'm going to use the cancel down method where I say 2 goes into itself once and goes into 16 8 times. And that gives me my 25 over 8 plus 1. Horrible. 2 outside of x plus 5 on 4 all squared. Now, again, we'll do it in the head, and I won't do a thought bubble this time. 1 is just 8 over 8. So we're really saying minus 25 plus 8. And minus 25 plus 8 will give me minus 17. So it'll be minus 17 over 8. And that puts it into the completing the square form that we've been used to by now. Okay, I think that's probably enough talking now. A bit of a long video, so sorry for that, but hopefully these examples will help you get through any problem that's thrown at you. Bye!